In this video, we're going to talk about regression. So if you have pairs of data sets, how you can describe the relationship between them. So given a collection of paired sample data, the regression equation y equals a plus bx describes the relationship between x and y. And this should be true if x and y have correlation. So we talked about correlation in the last video. So if there is correlation, we have this regression equation, which our calculator will help us find. Okay, so this exact same way that we found the R value, the A and the B are also shown in that menu. So we use the regression equation, like I said, for predictions only if there is linear correlation. There are other types of correlation. They could correlate in shapes other than that are straight line. But in this class, we're only going to focus on linear correlation. If the regression equation is not useful, meaning there's not linear correlation, then we use the mean, the average of the y values, which we can do. We can find the average using one variable stats, just like we did back in chapter 3. So like this says, this may be found on your calculator using stat calc1, var stats, and then putting the L2 after it. Okay, so we're going to use this data set here. So Old Faithful Geyser, this is a geyser in a state park, or sorry, a national park. So can we predict the next eruption will occur based on the height of the last eruption? In other words, is there significant linear correlation between the height of a geyser eruption and the number of minutes until the next eruption? So we're going to put the height into L1, and we're going to put the time into L2. So remember, we go stat, edit, and to clear these, just remember you're going to go up and hit clear, enter. Don't hit delete or it'll delete the whole list and it's kind of a mess. Up here we're going to hit clear, enter. Okay, so we're going to put the heights in here. So 150, so I have to be careful. 150, 125, 140, 139, 130, 125. And then we're going to put the time. Make sure you put it in exactly the same order. Oops. Make sure you hit enter between each of them. Okay. So now we can hit stat, go over to calc, and we're going down to our linreg a plus bx. Okay, we want that L1, L2. And we can hit calculate. Now, you could draw the scatter plot by hand like I showed you in the correlation. For the sake of this video, we're just going to look at the graph. And that was an old regression equation. So excuse me there, we're going to hit zoom stat. So there's our scatter plot. And we can see it looks kind of negatively, but we'll have to decide if there is correlation. So we're going to go back and look at our R value. So our R value here is negative 0.66. 665 if we want to go 3 decimal places. So we want to compare that to the value in on our formula sheet. So what's our n here? 1, 2, 3, 4, 5, 6. So n is 6. So we'll go to 6 and we're going to use 0.01. So 0.917, which is much bigger than 0.665. So since R is less than the critical value, there is not linear correlation. So which this means the best predicted value, that a plus bx doesn't help us much here, will be the mean of the y value. So if we wanted to predict, here we're saying there's not linear correlation. The height doesn't really tell us how long. So our best prediction for when the next height would just be the mean of the y values. To do this, we're going to hit stat, go over to calc. Now, remember, we wanted it in L2, so here you'll see it in blue, so we'll hit second, L2. So our mean here would be 76.8. So that's the best prediction for how long it'll be until the next eruption, no matter how high the last one went. Okay, let's do one more example. So it says, can crickets really predict the temperature? So some people claim that there's a linear relationship between the temperature and the number of time a cricket chirps in 1 minute. The following data was collected from 8 random crickets. So that already tells us that our n is 8. Okay, so we're going to put these in. I'm going to pause this while I put this in because it will not be interesting to watch. Okay, so I've put these data values in. To look at the scatter plot again, I'm not going to draw it on here. You can draw it for yourself if you want, but we can look at the graph. You'll want to hit zoom stat again every time you put new numbers in there, so it changes the windows appropriately. If you want to draw it by hand, I recommend going by 100s for the x-axis and by 10s for the y-axis. Okay, but we can see that this does look like it's pretty positively correlated. So to find our R value, we're going to hit stat, go over to calc, and remember it's number 8. So what happened here? Stat, sorry, I rushed through that and we need to have L1 in there instead of L2. Okay. So our R here is 0.869. Again, to decide if we have correlation, we need to use our table from our formula sheet. So remember our N was 8, and if we use 0.05, we get 0.707 here. So since our number on our calculator is bigger, there is linear correlation. So now we can look at our regression equation. So here the A comes first, so we're going to put 25. We'll put 25.8 plus our B, so 0.054x. Okay, so now if we want to predict anything, the temperature from the cricket chirps, we'll put the cricket chirps in for X and we'll get out our temperature prediction. So we'd have 25.8. So here for predicting if there are 980 cricket chirps, what's the temperature? So 25.8 plus 0.054 times 980. So we have 25.8. And that on there. 25.8 plus 0.054 times 980. So we would predict the temperature to be about 78.7 degrees. And if we wanted to do it for 800, again, we'd do the same thing, but we'd plug in 800. So we'd have 25.8 plus 0.054 times 800. So we see that the temperature would be predicted to be 69 degrees. Okay, so that's how we use, if there is correlation, that's how we use the regression equation to predict values.